So I want to talk to you guys. I'll go over just a brief introduction myself. So first, it's after 4 o'clock. You guys are sitting there. I'm looking at you. You're looking at me. Did you all fill out the cards for the free Honda? No one? I'm sorry. I guess we forgot to announce that. But just to talk about a little bit of my company, who I work for. So I work for a manufacturing company, Honda. And I work for the manufacturing company that's actually in Alabama. So if I say something and you can't quite understand me, just write it down and I will get back to it later, just in case I use my southern drawl. But we started Honda Manufacturing of Alabama back in 2001. And we have 4,000 plus some odd associates working at that location. Our facility is around 4.2 million square feet of facility. So it's a very nice sized facility. And there we have invested in Alabama probably around about $2.1 billion of capital investment, and we're steady growing within that location. So we're adding constantly and expanding our operations in Alabama. The models and everything that we produce is we are the sole producers of the Honda Odyssey, the Honda Pilot, the Ridgeline, and also the Acura MDX, more so the 2014 model that's coming in. And what's very different about our actual business model is we're not only just a frame plant. We don't just assemble the vehicles. We bring things in on a coil of steel, and we bring blocks of aluminum in. We cast and melt down our engines, our blocks and heads, and we cast them and build them there. So we have our huge engine facility, and then we bring our steel in and coils, and we go through the blanking process of actually making it flat and stamping out our parts and going through that whole weld process, and then we go through the assembly part of putting the vehicle together. So it's pretty much kind of a soup to nuts kind of a concept when you look at our manufacturing process as far as where we are. Our current capacity today as far as what we're producing is we run about 360,000 vehicles annually in engines from a capacity perspective. That breaks down to we do about 1,875 vehicles a day. So just kind of talk about from a volume perspective. Just to talk about who I am, my role at Honda is pretty much very plain and simple. I'm the plant floor IT manager. It's very basic in that perspective. I work in the IT department, and I deal with plant floor equipment. I have a team that's of about 25 associates, and what we deal with is PLC programming. We deal with things from not just PLC programming side, but also the IT applications themselves. So a lot of things that we're starting to see, especially since the 2000s, we're starting to see a lot of emerging technology that's happening. So what you see is you start seeing smarter devices on the floor, so therefore there's a need for more of an IT focus with embedded IT. You're starting to see Windows embedded and other things that's out there in equipment that's at a much cheaper pace and cost. So from a PLCs, as far as what I have here, we're primarily an Omron shop, but we're a mixed bag. We're Omron, we're Rockwell, we're Mitsubishi, and also on the robotics side, we do some things from a Fanuc, Yaskawa, Motorman. So you can see we have a very diverse background. So not only do we do a lot of different stuff in Alabama, but we also have a very diverse background of products and equipment that we have to support. In that, as well as some of the applications, our MES system that I'll talk about a little bit here as far as what we use as proprietary is something that was custom developed by Honda. And we also use things from we're a database, we're an IBM shop from a DB2 perspective. We're a SQL shop as far as the platforms that we standardize on as far as what we run our applications. And then we use some other things that we use some things like analytics. So there's a product that's out there that we refer to as Active Plant, which is a very nice product as far as collecting kind of a instrumented equipment concept when you're collecting analytics on top of that. So what I come today really is just to talk to you guys about 3 main concepts. And in these 3 concepts, really what I want to discuss is the first item is just talk about is how can you improve your IT resources. And I want to look at that and show how we did it using simple common tools. Some of the challenges that we have to face within Alabama, as I described, our environment is very robust, is that we also have to deal with the ramp-up of production. So we are the global manufacturer. So if you buy a Honda Odyssey or you buy a Honda Pilot, it doesn't matter where you buy it, where you get it in the globe, it came right out of Lincoln, Alabama. Because of that nature of our market space, we have to have the ability to be able to ramp up and ramp down production in a very quick, right, and passionate kind of way of doing it. We like to set a harmonious flow. So we'll look at that. But we're challenged with keeping our staff size the same. So when the economy is doing really well, we have to be able to expand and increase our capabilities and maintain our staff size and be able to do more with pretty much less or the same amount of resources. And obviously when the economy is in decline, we have to deal with it that way. One of the other challenges when we start looking at from an IT perspective is that we went through a reorganization. And what we did was we brought our IT and our plant floor resources together under one department. So that was a very interesting concept because all of us, right, if you're an engineer in this room, you've been taught to keep your control systems separate from corporate, right? And when you say corporate, they always meant IT. So it's very interesting to have an IT guy stand here and talk to you about control systems, right? But we had to bring all of those in and centralize that into one focus. And the main focus was on how do we improve production? How do we improve our efficiency? How do we improve the overall quality of our systems? And looking at everything that we do within those processes. Because like I said, we have a mixed bag. We bring them in as coils of steel, blocks of aluminum, and out we give birth to a Honda. The other part of it is that a lot of innovation is happening is around the IT area. So just like your car is getting more technical, you notice that you've got now the nice little touch screens, you got Pandora, streaming audio, everything. You're starting to see the same thing in the manufacturing space. On the production floor, we see that same type of innovation. You have a lot more IT, embedded IT products that's involved. We also have some of the things as far as one of the challenges that we're looking at was, we have to increase our commonality between our plants. And the reasons why that was important to us or more to improve that was because we say lean manufacturing and we have to stay lean and agile and flexible from the manufacturing perspective. But at the same time, we have to maximize our growth, right? Take advantage of market when it exists, right? So when sales and volume increase, we want to expand and grow from that perspective. So when you say lean, you think of from a very small, right? I'm slimming down process. When I say expand, increase my capacity, you think of growing. So in nature, those two have a fist fight, right, with one another. So one of the things that we had to do was look at how can we increase commonality between the plants as far as what we're doing so that we can really kind of win that battle, that constant struggle that we have. Is almost a fight between your brother and your sister, right? Two siblings where you're going through and saying, okay, I want to be lean, but yet the other guy wants to grow and get larger. So we had to deal with that. One of the other challenges I'll talk about is also how do we improve our product quality. And when I talk about product quality, not necessarily talking about the quality per se from the vehicle that you know Honda to be, but more so as far as the things that we're getting from the factory floor is more advanced. The data set's larger. The images, your cameras, I mean, think about it. You get a 12 megapixel camera on your phone today pretty much for almost a $99 cost out of Best Buy. So the images that you get from what we can take from equipment means that we can take advantage of technologies where we get much more crisp images. But that data set, what we have to store is a lot larger. So we have to deal with that. So it's better quality, better snapshots, more analytics, more data we can collect from that. But what that means is that it slows us down. More data means for us, from an IT side, is slower speeds. You're increasing the size of my database. You're increasing the amount of search records that I have to look at, right, from a historical point of view. So those were the three challenges that we'll look at. One, how do I improve my IT resource utilization? Okay, how do I increase my commonality between my plants? And then the third one is how do I improve my overall quality? So the first goal we had was just looking at as far as how do we make sure that we improve our resource utilization was looking at from a reduced code concept. So we're saying, okay, hey, we have a MES application system that's out there that we use to manufacture our product inside of our plant. And it's built on a large Unix platform. The whole purpose of what we have today, and if you look here, the blue boxes that are shown that they're developed internally, we've taken everything that's vertically inside of that application stack, from device drivers that's connecting out to the factory floor, to the program logic, the configuration, the application interface, everything that's associated with that. The whole thing is custom developed. It's a Java-based application that we wrote in-house. We didn't buy a packaged solution or anything. We basically customized and developed this application for our business needs to meet the needs of our delicate business or a delicate business that we run in Alabama. So it's custom development. The piece that I really want to focus on here was talking about how we took certain sections or modules of it and we looked at the equipment interface. Now this system, it works well. It's great, right? We love it. But, however, it is somewhat expensive to maintain when we look at new change points and things that are happening in the marketplace. So if I have a brand new device I have to roll in, I have to go in and I have to develop something from this perspective, from a device driver, or maybe there's program logic, or there's something else I have to look at that's with us in this application stack that I have to spend hours to go in and do custom development. It's not as quick and fast-paced as I would like for it to be. So we went down this path and we started migrating this application. And so what we did was we added an OPC-based solution. What we went after was we said, you know what? We don't want to spend 6 weeks of development writing drivers to connect to equipment every time we get a new device. We want to go out there and look at what's prevalent in the industry, bring in implement something from a software perspective, and have it so where we can just buy connections. We just wanted to buy drivers to equipment. So we did that. However, when we did that, when we went back and kind of did a review of what we did was, we went to one vendor provided perspective, but we still had a lot of complicated custom code that we went into. So we still had an application interface. We still had configuration data that we had to go into side of this MES application that we had. So it still had a lot of heavy custom code. It was still kind of that PC Mac commercial, right? I love to use that where we talk about the fact that the PC was kind of heavy and fat and the Mac was nice and slim. So the piece that we've been ramping into now going into this current platform and what we're ramping into production with today is that we've used a product called DeviceWise. And what DeviceWise has really allowed us to do is to bring in pretty much a common, what I refer to as just one simple common interface from a factory floor perspective. Tongue-tied. I guess the time is after 4 o'clock, right? But what that allowed us to do was to simplify this architecture and allowed us to pretty much bring everything into one particular platform. So what that did was that, as you can see as the boxes from a color change, that allowed me to move a lot of this business logic, the device drivers, everything from this concept, moving that down into the actual factory floor equipment from a space perspective. So I talked about, just from a comparison side, my custom solution. It's all customized. I have a large staff I have to do to maintain it. We do have some things when we start looking at from a data extraction perspective, but it was our original system that we put in back in 2001 from migrating that system. When you look at as far as what we did when we added the OPC package, we did actually accomplish something. We actually took something that we were actually having to custom write, and we were able to buy drivers. So we were no longer in the driver writing business, but we still had to do a lot of custom integration, more still custom code that we had to write to go to integrate our manufacturing system. So what happened was I didn't replace one for another. I ended up with 2 systems here. I had a blended system. So now I got this custom system I have, and I also have this package system. And it was still kind of had its own issues, right? We still had some issues where we had around slow response time, problems where we had what we refer to as data buildup and transit. Essentially what that means is that because from that technology perspective, I cannot see a machine transition state from on and off in the time period that it could do it. So therefore, because I couldn't detect that state, that means they had to wait for me. So they had to go off, wait 3 seconds, then go on, just so that I could see that transition state. So those were some of the things. And then we also had configuration problems as far as some of the things that we were looking at. Because, after all, we are dealing with a custom solution that we're integrating into. So the part that we're ramping up into production now is primarily looking at DeviceWise. And as I said, what this does for us, it took this blended systems, these 2 systems that I have here, and it combined those 2 systems into one system for me. And what this allowed me to do is I can run on multiple platforms. It gives me a lot of flexibility from an architecture standpoint. And I'm not just really backed into, per se, one vendor. So it gave me a lot of flexibility as far as some decisions that we can choose as far as how we go down the road. So when we look at that requirement, especially from a flexibility perspective, Greg got up here and talked about leveraging information from an information-driven side. And one of the things he said was you have to stay competitive. Right? You have to drive decision-making. a lot of that, when you look at that, that means to me, from a Honda perspective, is we have to stay flexible within our systems. And we have to do that in all layers of the application architecture, not just from within inside our apps, but we also have to deal with it on the factory floor side as well. So when you look at that, we had to build something that, or select a product that was scalable. It had to be both high available. It had to support large factory implementations as well as small factory implementations. And we developed different standards around that. So we went with these large Unix systems that we put in our large factories because we wanted really high availability, or what we refer to as like 5 nines of availability. We also looked at things from a small factory perspective. And these guys, they needed to have maybe a lower cost, smaller footprint because we had smaller data centers or different things in those locations. But we still needed to have the functionality of what this platform provided to us. The other piece was looking at special situations, satellite operations, unique equipment or suppliers. Maybe we had these, and we do today, these little one-off situations where it's a piece of specialized equipment, or it's a certain supplier that maybe they do this one function for me, and I need to extract that data to me, get it back into my enterprise application, or maybe I want to manage it with my overall ERP systems. All that stuff we need to get in to make sure that the platform we selected was very scalable when we looked at it from a production platform. The other side of it had to do with from a performance side. We had to meet the performance, right? We say as good or better from that perspective. We had to meet the current plant performance, the requirements. So what was the equipment? Today what we see, especially on the factory floors, as the PLCs are migrating from CPUs to CPUs, they're getting faster. So we're seeing a faster scan rate capabilities. So no longer looking at milliseconds, but you're looking at microseconds, and now starting to move into nanoseconds with some of the latest PLCs. You're also starting to see dual core, quad core processing cards that's running actually out there in your factory floor equipment. So if they're putting this kind of power out there on your factory floor, you have to be able to accept that performance in your enterprise system. If not, why are you buying that equipment? It's almost like a stereo system that you can't hear. Other piece of that we want to do is we want to go through and make sure that we pick and choose. So we need to choose certain functionality, right? So maybe I need this function here, but I don't need it over here. So the system had to be flexible and scalable from that standpoint so that I can pick and choose what parts of that enterprise architecture that I want to use. So this is just a nice little screenshot here, just kind of going showing what that architecture really looked like. And what we're able to do is pretty much kind of scalable these multiple architectures was from a large plant perspective, we had centralized control. We had the ability to have satellite operations. We had direct in-rack systems. So we ran things here from an enterprise perspective that was out here in the IT data center or in the cloud from that concept as well. But we could also run an in-rack module out to the production floor. So you really have flexibility. So depending on what the situation was, what was the business case or the use case around that particular implementation, we could look at it and say, okay, hey, I can run DeviceWise here locally because maybe I got some high performance requirements that I need really to have around sub-millisecond type of performance going on. Or maybe it's not time critical, it's not really time sensitive, it doesn't depend on latency, so therefore I can communicate back up to the enterprise inside of my data centers and communicate back out to the factory floor. And in other pieces, if you notice here, we also had more, I would say, vendor agnostic. So it didn't matter. I could deal with Control Logics, I could deal with Mitsubishi, I could deal with Siemens from that perspective, I could deal with Omron. It didn't matter. And I also had flexibility from a implementation standpoint. So here we have a pneumatic tool that we're using that's basically tied to what we record, like torque values, like more like a power wrench. That's connected to a PC. And so I could run this and I can collect that data that's downstream. And I can have nested information or nested devices below that. And so I could create somewhat of a small kind of common architecture around that. And then I can feed that up into my enterprise, into my large systems. So if this was a satellite operations, I could go in and get that, whatever pertinent information was what I wanted to capture to feed into my ERP systems, I could do that. Or I can feed it into my MES systems. From a small plant perspective, I can deal with that same way, where we like to run them on Linux, but the biggest point was we still want to have that one functionality where we can maintain some kind of central control. Regardless, however, whether it was a large plant implementation or a small plant implementation, we still, in both cases, we can integrate using web services. We can use message systems where we're using WebSphere MQ, or we're using the Microsoft messaging. Either way, from that perspective, we can get back into the MES system, and we can develop pretty much a lot of flexibility within that for our plant architecture and for our MES systems. So one of the things I talked about was around improving the data quality. And when we talk about handling the quality of data, the biggest thing is from an information-driven production standpoint, when you start looking at intelligence and instrumented from that perspective, what that means is, as I said, you grow your data set. So you have a lot more information that you're collecting. And once you do that, you start having a lot more functionality. So we got into the point where the original tools didn't really handle the load that well. And we went after something to have where we can have more of a distributed architecture. Or we had to really complicate the configuration of that plant floor device to handle the new type of information we wanted to deal with. So we went after this whole concept of we wanted to simplify the plant floor device. We wanted to really remove a lot of this complex business logic that was buried inside of the PLCs, but we wanted to simplify that and move that maybe to a higher functioning device so we can write that from an application standpoint. Get to a point where we can get to a cheaper platform to write that logic, because the simpler you can make it, the more people can understand it, and it really allows you to utilize your staff entirely, so you don't have to have a group of specialists. At that point, everybody can work on it, not just one or two people. And we wanted to make sure from this perspective that our PLC scan rates were not impacted by enterprise activities. So like one of the examples here, as far as from a data load quality perspective that we got into, was just looking at a simple concept of, I have a part serial number, and there are 1 million parts that's installed in that vehicle that have a serial number, and I want to keep up with that. So what I want to do is I want to go and I want to check that part serial number history-wise, just to make sure that part hasn't been showing that it's installed, or it doesn't have maybe a defect that's been shown on it that's out there. And what I want to do from a factory floor perspective, in the past what we had to do was take the PLCs and we had to retain that history inside of the equipment. And anytime, if you're especially if you're a controls guy, if you add more data to your PLCs and you got to search, what that does is that slows your overall scan times down. And because the PLC is a continuous cycle, sometimes if you get your scan times way out of whack, then you start missing data. So one of the things what this platform really helped us to do was to go in and use simple things like web services, to so where now I can use kind of software query as a service, and I can take those searches to say, hey, do this part serial number lookup for me, and send it to my enterprise system, hit my database, do that query, and respond back to me either yes, it's used, or no, it's not, or it's on this VIN number, or it's on this vehicle, or it's not. Very simple kind of concept. So what that allowed us to do was really take some of that very complex logic that we had developed inside of that piece of equipment and move it to a enterprise system and really help the performance associated with that. So just kind of going through summarizing exactly the items I went through here was primarily 3 things that I was talking about. But the main piece here is just talking about growth in your business, and especially from an equipment data perspective. Especially when you're looking at information-driven production, you're talking about more analytics, more instrumented devices, more devices that's going to provide you, I would say, larger data sets. So you have to look at that growth and manage that growth. And I've showed you a product from DeviceWise that basically allowed us to be able to do that. The other piece of that is I had the challenge of maintaining my staff size. Throughout this process from once we started this team, I haven't increased my staff at all. But I've been able to increase the number of systems that we've been able to take over and manage, and we've migrated those platforms. And what we did is we just basically evolved those systems. We went through and looked at that architecture, and we went through the process of slimming it down. So we achieved the concept of staying lean, but maximizing and improving our capacity. The other piece of this is the example, especially from this, is what we went through. We improved our delivery speeds. So we were able to speed up the decision-making process at the machine level. We're able to provide more decision-making capabilities at the machine level. because I'm able to access information that's running actually out there in the enterprise, not having to store that inside of the machine logic itself. We're also able to reduce our complexity. Simple configuration, simple setup means that more people can support it. More people can look at that setup, that configuration. They can look at that code and understand exactly, step by step, what is it doing. And last but not least, but we were also able to improve the quality of the equipment data itself. So we were able to offer our customers on the factory floor pretty much a better product in return, and give them more information to do more decision making right there on the factory floor. So that's all I have.